Welcome everybody. This is our first set of video solutions for Math 302. We're in the spring 2023 semester here at Cal State Fullerton. And this first quiz is going to be about sets and functions. So let's look at the first problem. Let's see. It says all but one of the following sets equals the empty set. Okay, we got to read that carefully. All but one equals the empty set. So that means most of these are the empty set. There's just one that isn't the empty set. So we just need to figure out which one that is probably, right? In fact, let's read the question down below. Determine which of the above sets is not the empty set. Good, good. Okay, so then what do we want to do once we know which one's not the empty set? We want to find the cardinality. Okay, remember the cardinality of a finite set is just how many different elements are in the set. All right, so let's take a look at these one by one. So first one, note this is set builder notation. All right, so we start with a brace, but then there's this big bar in the middle, and that tells you what happens before the bar. This is the form, right, what things look like. And then what happens after the bar is the condition, or conditions. In this case, there's just one condition. Okay, so we're looking at, remember this symbol means the integers, so we're looking at all integers, such that when you raise that integer to the fourth power and add 5, you get a negative number. But if I take a number and an integer, say, raise it to the fourth power, I'm definitely getting something at least 0, right? 4 is an even number. Even powers give you non-negative answers. So this is already at least 0. Add 5, it's at least 5. So it can't be negative. So this set is equal to the empty set. All right, let's see next. The intersection of a set and its complement. All right, so remember when you have a set and its complement, the complement is everything not in the set. And if I take the intersection, right, so say I call my set S, and I take the intersection with the complement of that set, now I'm looking for everything which is both in S and, so remember intersection here means it's going to be in both sets, and it's in the complement. And the complement was things not in S. So you cannot have something which is both in S and not in S. So this intersection must be the empty set. All right, next one. Again, it looks like we're given something in set builder notation. We're looking again now at all integers such that, okay, the integer n lies between 1 and 7. So we're really just looking at 2, 3, 4, 5, or 6. Okay, and so there's a second condition. 2023 divided by n leaves a remainder of 0. So we need to divide 2023 by these numbers and see which gives us a remainder of 0. Now, I could do this in long form, but of course there's some little tricks, right? Like for example, 2023 is odd, which means it's not even, which means it's not a multiple of 2, right? If you divided 2023 by 2, you'll get a remainder of 1. So I can kill 2. But also 4 is even, and 2023 is odd. So I can kill 4, and 6 is even, so I can kill 6. Now this 5, that's kind of the next easier one. You know that a number is only divisible by 5 if it ends in a 0 or a 5. So this ends in a 3, so it's not divisible by 5. Okay, finally we have the 3 here. And either you know the nice divisibility trick, which we'll actually prove later on in the semester, where you just have to add the digits, and if the sum is divisible by 3, then the number is divisible by 3, or you could just divide it longhand. All right, so in this case, 2 plus 2 plus 3 is 7, which is not divisible by 3. Or you could say, okay, 2023 divided by 3. 3 goes into 20 6 times. 2 left over, drop the 2. 3 goes into 22 7 times. Let's see, 1 left over. 3 goes into 13 4 times. 1 left over. We're done. Remainder of 1. It's not a remainder of 0. So the 3 doesn't divide into 2023 either. Actually, it's kind of nice. There's only 2 prime factors in 2023, 7 and 17. In fact, the 17 goes in twice. So this is also equal to the empty set. All right, let's look at the next one. All right, this looks confusing. So I have something that to a lot of people, they'll think this is the empty set. but it's not. You have to be very careful here. This is not the empty set. It is the set containing the empty set. It is a set with exactly one element, and that element is the empty set. So we've got to be careful there. All right, now we take a union. So that means we're going to look at things that are either in the set on the left or in this set on the right. This whole big thing, right, which is bounded by these parentheses. Okay, so let's figure out what this set on the right is. Well, it's given by an intersection. Oh, all right, we got this nice intersection here. Oh, it just goes away when you do it in purple. All right, so there we go. I have an intersection of these two sets. All right, now what are the two sets I'm intersecting? Well, this on the left has 5 elements, A, B, C, D, and E. And on the right, I have 5 elements, 1, 2, 3, 4, and 5. There's no element in common. When I take the intersection of these two sets is equal to the empty set. So I can rewrite this expression as the set containing the empty set, that's the yellow bit, union the empty set. Okay, that's the other bit here. And again, this is where it's very important that you recognize the set on the left is not the empty set. It is the set containing the empty set. So I'm looking now at a union of two sets. One set has a single element, and just to make it maybe easier to see this, let me just call this briefly A. Okay, there's an element, happens to be the empty set, but we don't care. So there's one element, it's called A. And I'm going to take the union with another set. But again, let me rewrite this using our other notation for the empty set, which is just the braces with nothing in between. So I'm taking a union of the set containing A and a set containing nothing else. And when I take such a union, I'd say, well, what's all the elements that are in either one of these? And the answer is, well, there's just one element, namely A. Okay, but of course we can rewrite this now as the set containing the empty set. And note, this is not equal to the empty set. There is one element. In fact, this answers the question here. Okay? The fourth one is the one which is not the empty set, and the cardinality, so the cardinality of the set containing the empty set is 1. Now, just as a make sure we didn't skip anything, right? Let's look at the last one. The set of all sets, ooh, that's confusing, that do not contain the empty set as a subset. Okay, so let's try to write this in set builder notation. So I'm going to take a set, okay, so I use a curly brace, and the things in here are going to be, well, let's write S, and we'll just say it's a set, okay, that we tell what the form is. S, a set, such that do not contain the empty set as a subset. So the empty set is not a subset of S. But the empty set is always a subset of every set. For any set, the empty set is a subset. Why? Well, this comes down to the definition. The definition of subset containment is if every element of the set on the left is an element of the set on the right. Well, there are no elements to check, so it's true. Every element of the empty set, there are none, is an element of S. Okay, so there are no sets that satisfy this condition, and so this set is the empty set. All right, so that's our first problem from this quiz. We'll see you next time for quiz 1, problem 2.